Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York, and this is 5th grade math, module 6, lesson 14. Today, we're going to construct parallel line segments and analyze relationships of the coordinate pairs. So let's look at we have a coordinate plane here, and we're going to use it for these letters A, B, C, D, E, F, and G. Letter A says identify the locations of M and N. So we have M right here, and we have N right there. So we read our x coordinate first. We'll go across here. Looks like each one of these little boxes here is 1. And we have 6 as our x coordinate. So I'm going to come right down here into my box for M in the x coordinate, and I'm going to put a 6. And then for my y coordinate, I move up my y-axis. I have 3 plus 1 more is 4, it looks like, for my y coordinate. So it'll be 6, 4. I'm going to do the same thing for n. N looks like it's going to be 3, 6. And then it wants us to draw line MN. So I'm going to connect point M and N. And it doesn't look like it's not asking us to do a line segment. It's saying a line. So we'll do a full line here. All right. So you have line MN here. And now it's asking us to plot the following coordinate pairs in the plane. So we have J, which is 5, 7. And 6, 1 before 6 here is 5. Here's 7. So I'll make a point there, and then this is now the point J. And then I have point K, which is 8, 5. 8 and 5. K. And now I'm going to draw a line JK here. So I have a letter E. It says to circle the relationship between MN and JK. Are those two lines perpendicular or are they parallel? Well, perpendicular is kind of like this X and Y axis here where it forms a right angle. So it's not perpendicular. It is going to be parallel. These lines will never cross as far as they go in either direction, and they are an equal distance apart the entire way. That's how we know that they're parallel. And it's asking us in letter F here to give the coordinates of a pair of points, F and G, such that the line FG is parallel to MN. So we have to make another line that will be parallel to this line. And the way I'll find a parallel line, like I was saying, is that if you do any point, as long as the second line is the same distance from one point as it is from another, that line will be parallel. So, for example, if I have letter N here, I can go, let's say, go down 2. 1, 2. I'm going to put a point here. Well, if I go to any other point on this line, and I go down 2 units, so if I go to M and I go 1, 2, right here, this line will be parallel because it's the same distance away from N as it is from M. And so we'll call this one here letter F, and we'll call this one letter G. If I put it there, I'll put my line right through it. So let's put it here, F, and this one will be G. And F is 3, 4. And G is 6, 2. draw our line right here. There we go. We have another parallel line. Let's move on to our next one here. So we have another coordinate plane, and it says use the coordinate plane to complete the following tasks. It says identify the locations of A and B. So now we have to look at A and B here. And we have letter A is 4, and it looks like, well, we have 3, and then another line in between, and then 4. So this is going to be 3, 3.5, 4. So each one of these increments here is going to be a half. So we have 4, 3.5 for A. And then B is 2, 3. Now we have to draw a line AB. All right, so we have line AB. It says generate coordinate pairs for C and D such that AB is parallel to CD. So we have to make a point C and a point D. If we want to make those lines parallel, again, we want to move the same distance down on our coordinate plane for each point. So let's go to B, and we'll move that B down 1, 2, 3. We'll move it down 3 of these boxes, which is really 1.5. And then we'll move A down 1.5 as well. 1, 2, 3. 3 halves, which is 1.5. We'll call this here point C, and we'll call this point D. And C will be 2, 1.5. And D will be 4, 2. And we'll draw a line CD here. All right, so we have 2 parallel lines there. Now it says, explain the pattern you used when generating coordinate pairs for C and D. Well, we moved the same amount of units down from point B as we did in point A, and created 2 points that were the same distance away from, relative distances away from those points. So that way we know this line will never touch this one as far as we go in either direction, the same distance apart the whole way. Letter F tells us give the coordinates of a point F such that line AB is parallel to line EF, and it gives us a point for point E here. It gives us coordinates, so 2.5 and 2.5. Coincidentally, this is going to be right in between our 2 lines here. So let's we'll make this point E. And we'll have to make a point F such that AB is parallel to EF. So if we want it to move through E and be parallel, we'll have to take another point. So down 1 over 1 to get to E. Get it off the screen a little bit there. So B has to move down 1 and over 1 to get to E. So A will have to move down 1 and over 1 to get to F. And this coordinate here will be 4.5, 3. So again, if you look, I moved down 1, over 1, and I did the same thing with point A. So as long as I move the point the same way, I'll end up with a parallel line. Draw that right now. Line EF. And as you see, we have another parallel line here. So it's not just necessarily for the first line we did with 2 lines we moved that point just down, but we can also move down and over 1, or we can move over to the right 2 or over to the left 2. As long as whatever we do to point A, we do the same thing to point B, then we're going to end up with a parallel line. So in EF, we moved down 1 and then over 1 and got another parallel line EF. So that's how we got the coordinates for F. All right, and that is all we're going to be doing for today. So thank you guys so much for tuning in, and I look forward to seeing you next time.